So we decided before that we'll be solving for the moments at different points. So how do we solve for these moments? We use the magic matrix moment. The matrix that we have here. So we have shear, moment shear, and moment shear, and then we have all the respective terms in the matrix here, and then we have the deltas and thetas of the respective shears and moments. So to this equation, we add up the fixed end moments at each point if when they're present. So we first need to calculate the fixed end moments. So here we have the fixed end moments calculated, and this is how we came with the fixed end moments. So in the back of the book, we have already pre-solved fixed end moments for our given problem. But then, because of the sign convention that we have used compared to the textbook, we'll have to change positive to negative and negative to positive. So here you see that at A, it's going in a counterclockwise direction, but we've taken it to be going in clockwise direction. So we have to take a negative of this moment, what they gave us. Same thing with this. And then we need a shear from here. So we sum up the moments at B to get the shear. So we have shear VBA equals to 3WL by 20, and we solve for that too. So first we have the fixed end moment at AB, which is given down here, negative moment, negative WL squared by 20, and we solve for it, comes up to negative 972 cubes per feet. Same thing with fixed end moment at BA, we have that solved. And then if you remember the picture from before, you see that there is no other loading that's happening on BC or CD. So the fixed end moments on BC and CD would be equal to 0. So that's what we have here. Fixed end moment of BC equals to CB equals to DC equals to CD, which are all equal to 0. So now we have this. So now using the matrix equation, we will solve for all the required moments. Those would be, for example, moment at AB. So we'll be solving for moment at AB, moment at BA, moment at BC, moment at CD, moment at DC, moment at CD, as well as the shears from the equilibrium equations that we needed. So, go.
Okay, from our equations of equilibrium, we see that moment of BA is equal to BC, moment at CB is equal to CD.
Negative.
Oh, negative CD, I'm sorry. And the moment at D is equal to 0. And we also have the shear at BA plus the shear at CD is equal to 0. Now, if you go through and evaluate each beam separately, you can solve for the moments and shears that you need from that section, so you can set up your equations and solve for your unknowns. So from beam AB, we have the moment at BA is equal to this equation in terms of our unknowns, and we also solve for the shear in BA. From BC, we have the moment of BC and the moment of CB. And then from beam DC, we have the moment at DC, the moment at CD, and the shear about CD.